First step always is to factor. Yes? Yeah. Now, factoring when you have a negative x squared, I always find that makes it a little bit more difficult. So if I factor a negative out of the whole thing on the top, and then factor the inside, to get 2x squared is 2x and x. To get 2 is going to be 2 and 1. I'm going to need the 2 here and the 1 there, so that when I multiply my outside and my inside, I get 4 plus 1. They both need to be negative to get the negative 5x. And it's still all over x minus 1. So step 1, non-permissible values. Do we have any? X can't equal 1. Is that going to be a whole or a vertical asymptote? Vertical asymptote at x equals 1. Do we have a horizontal asymptote or an oblique asymptote? Okay. Now you might remember that if the degree is higher on the top and it doesn't cancel out to give you a whole, then you're going to get an oblique asymptote. If you use the shortcut and look at the highest power is x squared. We have minus 2x squared on the top. We have no x squareds on the bottom. This is not possible. You can't divide by 0. That's why it's oblique. If the non-permissible value doesn't simplify away, then it's going to be a vertical asymptote. So to find the equation of your oblique asymptote, you're going to have to use synthetic division to divide or long division to divide. We have negative 2x squared plus 5x minus 2. We're dividing by x minus 1, so you put opposite sign out in front of plus 1. Bring down the number. Multiply, add, multiply, add. And you can ignore your remainder. Your oblique asymptote will be y equals negative 2x plus 3. Step 3, we can find all of our intercepts. Y-intercept, plug in 0 for x into your original equation, and you will get negative 2 over negative 1. For your x-intercepts, again, you plug in 0 for y. We'll look at our factored form. The only place, if I put in 0 for y, the only place a fraction is equal to 0 is if the numerator is equal to 0. So if I look at my numerator, which is already factored, what would make that 0? So you have an x-intercept at 2 and 1/2. So now when we go to graph, we'll see, do we have enough information to graph this completely? We know we have a vertical asymptote at x equals 1. We know we have an oblique asymptote at negative 2x plus 3. So what does that mean? We'd have a y-intercept of 3, a slope of negative 2, down 2 over 1, down 2 over 1. Oh, so close. That's better. And we can label that one as well. So there are our two asymptotes. Our y-intercept is at 2, so we know that it goes through this point, 0, 2. Our x-intercept is at 1/2. So we've got 1/2, 0, and at 2. So we've got 2, 0. Our vertical asymptote separates our domain into two sections on this graph. Horizontal asymptotes and oblique asymptotes don't break up the domain. Do we have points left of x equals 1? Yes, we have 2 of them. So we have enough information here to draw things towards the asymptotes. Do we have a point to the right of x equals 1? Yes. So we have enough information here to draw it towards the asymptotes. And there's our final graph. Question number 5 for practice. Oh, does it ask for domain?
Domain and range.
Domain and the range. So the domain of this one, the x values, it's everything except x can't equal 1. But x could be everything else. And your range, there is no smallest y value. There's no biggest y value. The range is everything.